You know, when you think about engineers and scientists solving the world's toughest problems, things like designing next gen aircraft or decoding complex biological data, you probably picture supercomputers or maybe some crazy expensive lab equipment. But what if I told you one of their most powerful secret weapons is something you can get for free right now?
So, what is it? What's this common thread that's been quietly changing the game for research and development in pretty much every field you can imagine?
Yup, you guessed it. It's a programming language. And in this explainer, we're going to break down exactly how Python became the undisputed champion for science and engineering, and what kinds of incredible things it lets people do.
So, really, why Python? I mean, for decades, these fields were run by super specialized software like MATLAB or old school languages like Fortran. How did Python just swoop in and take over? Well, it really boils down to three core superpowers. Okay, first up, and this one's huge, it basically reads like English. The code is just so clean and intuitive. And what that means is you spend way less time wrestling with complicated syntax and a lot more time actually thinking about the problem you're trying to solve, whether that's fluid dynamics or some new sensor data. It's built for speed, not just how fast the computer runs, but how fast you can get your ideas into code.
Second, and this is arguably Python's real superpower, is its unbelievable ecosystem of libraries. Just think of them as these pre-built, specialized toolboxes. You need to do some heavy-duty math? Guess what? There's a toolbox for that. Need to create some really sophisticated charts and graphs? Yeah, there's a toolbox for that too. And this quote just says it all, doesn't it? You're not starting from square one. With this huge collection of open source work, you're plugging into decades of brilliant work from a whole global community of developers and scientists. It's all right there, ready for you to use.
And the third superpower? The price tag. The whole thing is completely and totally free. Python and that entire universe of toolboxes we just talked about, it's all open source. And this is an absolute game changer. It just completely removes the barrier of those expensive software licenses, which means these incredibly powerful tools are available to literally everyone, from a student in a university lab to an engineer at a tiny startup. All right, so that's the why. Now let's get into the fun stuff and see what you can actually do with it. Let's take a quick tour of the essential libraries you'd find inside this scientific toolbox. So the foundation, the bedrock of almost all scientific Python, is NumPy. Its main trick is this super efficient array object that lets you perform really complex math on huge chunks of data at, well, ridiculous speeds. That's because the heavy lifting is actually done in a much faster language called C. This is the engine behind things like the matrix math you'd see in a structural analysis or processing a stream of data from a sensor. Next up, you've got pandas. And let me tell you, if you've ever had to deal with data in spreadsheets, CSV files, or databases, Pandas is about to become your best friend. It gives you something called a data frame, which is basically a spreadsheet on steroids. It makes loading, cleaning, filtering, and just generally making sense of massive data sets incredibly simple. Okay, so you've crunched the numbers, you've analyzed the data, but what's the point if you can't actually see what's going on? That's where Matplotlib and Seaborn come in. These libraries let you create pretty much any kind of plot you can dream up, from a simple line graph to a wild 3D plot. And honestly, it's about more than just pretty pictures. It's about truly understanding your results and being able to communicate them to other people. Now, for those times when you need to dig a little deeper and tackle some more specialized problems, that's where SciPy comes into play. It's built right on top of NumPy, and it gives you a whole suite of tools for the kind of advanced tasks you see all the time in science and engineering. So what does that really mean? Well, with SciPy, you could run an optimization to find, say, the absolute best design parameters for a new product. Or you could use its signal processing tools to clean up noisy data coming from a sensor. You can even solve complex differential equations to model how a physical system, like a car's suspension, behaves over time. It's seriously powerful stuff. And of course, no modern toolkit would be complete without machine learning and AI. With libraries like scikit-learn, TensorFlow, and PyTorch, engineers can now build models that predict the future. We're talking about everything from predictive maintenance on factory machines to using computer vision to automatically spot defects, or even analyzing medical images to find patterns a human might miss. So let's tie this all together, because talking about these libraries one by one is one thing, but their real magic is how they all play together. Let's walk through a quick real-world example for, say, a mechanical engineer. Okay, picture this. You're analyzing the stress on a new mechanical part. First, you'd use Pandas to effortlessly pull in all your simulation data from a CSV file. Then you'd use NumPy to run all your complex calculations on those stress values. After that, you'd fire up Matplotlib to create a nice color-coded plot that visually shows you exactly where the high-stress hotspots are. And to top it all off, you could even use scikit-learn to build a model that predicts when that part is most likely to fail.
And see, every single one of those steps, from importing the data all the way to a final prediction, it all happens seamlessly right there in one environment. And that is the key. It shows you that Python isn't just a programming language, it's this unified, integrated powerhouse that just massively speeds up the whole process of discovery and innovation.
When you step back and look at it, it's pretty incredible. It's easy to get started with, it's unbelievably powerful, and it's totally free. So it really just leaves one last question. With a superpower like this at your fingertips, what problem would you want to solve?